Hello, and welcome. Today, we're embarking on a journey that bridges the seemingly disparate worlds of mathematics, art, music, and postmodern philosophy. We're going to explore the legacy of Douglas Hofstadter's masterpiece, Gödel, Escher, Bach, and then push it into even stranger territory with the help of Jean Baudrillard. Now, Gödel, Escher, Bach, or GEB as it's affectionately known, is all about self-reference and recursion. It explores how systems, whether they are mathematical proofs, musical compositions, or visual artworks, can refer back to themselves, creating these fascinating, strange loops. Gödel's incompleteness theorems, for instance, showed that within any sufficiently complex formal system, there will always be true statements that cannot be proven within that system. The system, in a sense, points to its own limitations. Escher's art plays with similar ideas: staircases that loop back on themselves, hands drawing each other, creating paradoxical visual realities. And Bach's music, with its intricate canons and fugues, builds complex structures out of self-referential melodic themes. But what happens when we take this idea of self-reference and push it to its extreme? What happens when the copy becomes more real than the original? This is where Jean Baudrillard enters the picture. Baudrillard, a key figure in postmodern thought, developed the concept of simulacra and simulation. He argued that our contemporary society is increasingly dominated by simulations, copies without originals. Think of reality TV, social media, or even heavily processed food. These aren't direct representations of reality, they are hyperreal, more real than real. Baudrillard identified 4 orders of simulacra. First, the image is a clear reflection of reality. Second, the image masks and perverts reality. Third, the image masks the absence of a basic reality. And fourth, the image bears no relation to any reality whatsoever, it is its own pure simulacrum. So, how does this relate to mathematics? Aren't mathematical models supposed to be precise representations of the real world? Well, maybe, and maybe not. Consider a mathematical model of, say, the stock market. It uses equations, algorithms, and data to simulate the behavior of real-world financial systems. But is it the real stock market? Or is it a representation of the stock market? A map that can never fully capture the territory? And as these models become more complex, more sophisticated, they can start to influence the very reality they are supposed to be modeling. High-frequency trading algorithms, for example, don't just predict market movements, they create them. The simulation starts to proceed and determine the real. We might even argue that certain areas of pure mathematics, those far removed from any direct physical application, exist purely in the realm of the simulacrum. They are systems of symbols, manipulating other symbols, according to a set of rules, creating a self-contained, hyperreal world. They are beautiful, intricate, and internally consistent, but they have no original in the physical world. They are, in a sense, pure simulation. This isn't to say that mathematics is false or meaningless. Rather, it's to suggest that even in this seemingly objective realm, we encounter the same issues of representation, self-reference, and the potential for the simulation to overtake the real that Baudrillard identified in broader culture. GEB showed us the strange loops within systems. Baudrillard takes it further, suggesting that we're living within a giant, ever-expanding strange loop, a hyperreality where the distinction between the real and the simulated has become increasingly blurred, perhaps even irrelevant. So, are mathematical models just sophisticated simulacra? Is pure mathematics a self-contained hyperreality? And what are the implications of this for our understanding of knowledge, truth, and reality itself? Let's discuss in the comments. And if you enjoyed this journey into the simulated heart of mathematics, be sure to like and subscribe. Thanks for watching.